Assalamualaikum and hi, I am Nur Amilah Husnamilah binti Nazri from class A S2535A. Today, me and my friend Nurul Ika Syafiqah binti Muhammad Munir will give a presentation on a journal entitled Total Analysis of Microcysteines in Fish Tissue Using Laser Thermal Desorption, Atmospheric Pressure Chemical Ionization, High Resolution Mass Spectrometry. So, in the first part of this video, I will discuss the importance of analyzing the analyte from the sample. The investigation sample comprises fish tissue from lakes exhibiting harmful algal blooms, HABs. The substance under scrutiny in this particular inquiry is microcysteines, which are highly potent toxins generated by cyanobacteria commonly detected in HABs. The primary objective of the researchers was to formulate a novel analytical approach aimed at identifying and measuring the total microcysteines present, encompassing both liberated and bound fractions within fish tissue to deliver a more comprehensive evaluation of the pollution levels for the sake of judicious risk mitigation. Therefore, analyzing the analyte from the sample is crucial in environmental and food safety studies in several reasons such as risk assessment, detection of total microcysteines, quantification for prudent risk management, comparison with conventional analytical methods, and validation of analytical methods. In risk assessment, analyzing microcysteines in fish tissue is crucial for conducting risk assessments related to human and animal health. Microcysteines, as I said before, are potent toxins produced by cyanobacteria, and their presence in fish tissue can pose significant health risks if consumed. Next is the detection of total microcysteines. The study aims to develop a new analytical method to detect total microcysteines, including both free and bound fractions in fish tissue. This comprehensive analysis provides a more accurate assessment of the contamination levels compared to conventional methods that may only target specific microcysteines variants. Next is quantification for prudent risk management. By accurately quantifying total microcysteines in fish tissue, researchers can provide valuable data for prudent risk management strategies. Understanding the actual levels of microcysteine contamination in fish tissue is essential for making informed decisions regarding food safety and public health protection. Next is the comparison with conventional analytical methods. The study aimed to determine the possible undervaluation of microcysteines, quantification by conventional analytical methods that focus on individual microcysteine variants using available standards. By developing a new method for total microcysteine analysis, the researchers could assess the limitation of existing analytical approaches and improve the accuracy of quantification. Last but not least, a validation of the analytical method. Analyzing the analyte from the sample allowed the researchers to validate the new analytical method developed for total microcysteine analysis in fish tissue. Validation studies are essential to ensure the reliability, accuracy, reproducibility of the analytical technique, thereby enhancing the credibility of the study results. Therefore, analyzing microcysteines in fish tissue in this journal is crucial for assessing contamination levels, conducting risk assessment, improving analytical methods, and ultimately ensuring the safety of fish consumption and environmental health. Now, we move to the next part where I will be explain why the spectroscopic method is chosen compared with other methods. This is due to many reasons. First and foremost is due to high sensitivity and selectivity. Spectroscopic methods such as mass spectrometry offer high sensitivity and selectivity in detecting and quantifying analytes in complex matrices like fish tissue. The high-resolution mass spectrometry used in this study provides precise identification and quantification of microcysteines at low concentrations, which may not be achievable with non-spectroscopic methods. The second one is comprehensive analysis. Spectroscopic methods like HRMS allow for comprehensive analysis of total microcysteines, including both free and protein-bound fractions in fish tissue. This holistic approach provides a more complete understanding of total microcysteine contamination levels, which is essential for accurate risk assessment and management. Next is rapid analysis time. The LDTD APCI HRMS method offers ultra-fast analysis times, enabling quick processing of sample and timely generation of results. This rapid analysis capability is advantageous for handling a large number of samples efficiently, which may not be feasible with non-spectroscopic methods that require longer analysis times. The fourth one is method validation and reliability. Spectroscopic methods, particularly high-resolution mass spectrometry, are well established and widely recognized for their accuracy, precision, and reliability in analytical chemistry. By choosing a spectroscopic method like HRMS, the researchers can ensure the validity and robustness of the analytical technique, enhancing the credibility of the study results. Next is enhanced detection limits. Spectroscopic methods such as HRMS offer improved detection limits compared to many non-spectroscopic methods. The high sensitivity of HRMS allows for the detection of the microcysteines at very low concentrations, which is crucial for assessing the potential health risks associated with microcystine contamination in fish tissue. In summary, these factors collectively contribute to the effectiveness and accuracy of the analytical approach for studying microcystine contamination in fish tissue. That is all from me. Now we will move on to the next presenter.
Hi, I'm Ika. Now I will continue the presentation and I will explain a discussion on the information provided in the journal. The spectra measured in the article provide crucial information for achieving qualitative and quantitative analysis of microcysteines in fish tissue. The targeted ion fragmentation mode, TMS2, was utilized for MMPB quantification with optimal collision energies and specific fragment ions selected using Q-Exactive Tune 2.3 software. This approach allowed for identification of precursor and fragment ions, enabling accurate quantification and conformation of microcysteines. The method validation process involves selecting two fragment ions with the highest signal intensity for quantification and conformation purposes. By establishing method limits of detection and quantification, false positives were minimized and compound conformation was enhanced through the use of relative intensity ratios. The use of laser diode-thermal desorption (LDTD) coupled with atmospheric pressure chemical ionization (APCI) and Q-Exactive high-resolution mass spectrometry provided several advantages for the analysis of microcysteines in fish tissues. The LDTD technologies offered ultra-fast analysis times, small sample requirements, and reduced solvent usage due to the absence of liquid chromatography. The high sensitivity and selectivity of the Q-Exactive mass spectrometer with its quadruple precursor selection and high energy collisional dissociation cell facilitated precise quantification and identification of microcysteines. Furthermore, the method validation included evaluating recovery rates for the fish tissue digestion and oxidation as well as solid phase extraction (SPE) efficiency. By comparing peak areas of spike, sample 3, and post-extraction, extraction recoveries and metric effects were assessed, ensuring the accuracy and reliability of the analytical method. The calibration curve, internal standard selection, and determination of method detection and quantification limits further validated the robustness of the analytical approach. Next, I will continue on the comment on the data obtained from the article. The data obtained from the article on the total analysis of microcysteines in fish tissue using LDTD, APCI, HRMS provide valuable insights into the presence and concentration of these cyanobacterial toxins. The study successfully detected total microcysteine in fish tissues with concentration ranging from 2.9 to 13.2 microgram kilogram in samples from cyanobacteria contaminated lakes. The use of innovative techniques such as sodium hydroxide digestion, mimics oxidation, and LDTD APCI HRMS enable rapid analysis and high-resolution detection of microcysteines in fish tissues. Now, I will talk about the limitation and advantages of this analysis. One of the limitation analysis is the lack of isotopically labeled MMPB for the internal standardization, leading to the use of 4PB as an alternative internal standard. This limitation could introduce variability in quantification due to matrix effects. To address this, future studies could focus on developing isotopically labeled standards for more accurate quantification of microcysteines in fish tissues. Despite this limitation, the study demonstrated high recovery rates for digestion, oxidation, and solid phase extraction, ranging from 70 to 75% and 86 to 103% respectively. The method detection and quantification limits were also within acceptable ranges at 2.7 and 8.2 microgram kilogram respectively. These results highlight the robustness of the analytical method for detecting microcysteines in fish tissues. I will move to the next part, which is improvement for analysis limitation of this analysis. To further improve the analysis, future studies could explore the use of alternative internal standards or develop isotopically level standards for more accurate quantification. Additionally, optimizing the SPE procedure to enhance recovery value and reduce metric effects could improve the overall reliability of the method. Overall, the study provides a solid foundation for the analysis of microcysteines in fish tissues and offers valuable insight for future research in this field. For accuracy and precision, this method demonstrated high accuracy and precision with linear correlation coefficient R square of 0.999 for the validated method. The intraday and intraday variation coefficients for target compounds were below 10%, indicating good precision in the analysis. Next is about the sensitivity and detection limit. The use of LDTD APCR HRMS with the Q-exactive mass spectrometer provided high sensitivity for detecting microcysteines in fish tissue. The method detection limit MDL and method quantification limit MQL were reported as 2.7 and 8.2 microgram kilogram respectively, demonstrating the method's ability to detect low concentration of microcysteines. For selectivity, the hybrid orbital detector of Q-exactive mass spectrometer offered excellent selectivity for the analysis of microcysteines. The mass spectrometer enables precursor fragmentation and exact mass detection, enhancing the specificity of the analysis. I will continue explaining about robustness of this analysis. The method validation included evaluating recovery rates for digestion, oxidation, and solid phase extraction, as well as assessing metric effects. The method demonstrated robustness with SPE recoveries ranging from active to 103% and signal recoveries for metric effect ranging from 90 to 93%. That's all for our presentation on a journal entitled Total Analysis of Microcysteines in Fish Tissue using Laser Thermal Desorption, Atmospheric Pressure Chemical Ionization, High Resolution Mass Spectrometry, LTTD APCI HRMS. Thank you.